I think that will be all for your mechanical modeling of your system. So now let us proceed to electrical analogies. Okay, now we'll proceed to the electrical analogies of mechanical system. So in this case, we want just to show the analyzation on how can we, di ba kanina on the first discussion natin, we show an electrical system model having different mathematical models. So we have the differential equation model of your electrical system, and then we transfer it having a transfer function mathematical model of your electrical system. And then on the second discussion, we have the modeling of mechanical system. And then we show the model of the mechanical system according to its differential equation mathematical model. In this case, we analyze naman daw on our third discussion. We analyze naman daw the electrical system based the mechanical system based on its electrical equivalence or electrical analogy. So, sabi natin dyan, enable for us to analyze two systems. Sabi dyan, two systems are said to be analogous, or we can analyze or we can compare those systems to each other if they meet the following conditions. So, dapat ma-meet natin yung dalawang conditions na yun. Una, the systems are physically different. Dapat magkaiba. For us to analyze or to be analogous yung dalawang system, dapat magkaiba yung system natin. In this case, magkaiba sila kasi meron tayong electrical system and meron tayong mechanical system. So therefore, we meet the first criteria or the first condition, which is the system must be different. And the second condition is that the differential equation modeling of these two systems are the same. So meaning the come up or the differential equation mathematical model we come up for those two physically different systems are the same. Meaning, kung i-compare natin yung two different physical system and we convert those system or we analyze them having a differential mathematical model, we can say that their differential mathematical models are the same so that we can have the analogy of those two different physical systems. O sabi dyan, electrical systems and mechanical systems are two different systems. There are two types of electrical analogies of translational mechanical systems. Those are force voltage analogy and force current analogy. So sabihin na lang natin in analyzing a electrical analogy of a mechanical system, we can analyze the mechanical system based on two electrical analogy. First electrical analogy is a force voltage analogy, and the second analogy of your mechanical electrical analogy of your mechanical system is a force current analogy. So basically, kung titingnan niyo naman, from the term itself, we analyze the force according to the voltage. Ay siya tinawag na force voltage analysis or analogy. And the second type is we analyze the force according to current or in terms of current or electrical current. So therefore, kaya tinawag natin siyang force current analogy. So, isa-isa natin to. In force voltage analogy. In force voltage analogy, the mechanical equations of translational mechanical systems are compared with the mesh equations of an electrical system. So, we consider this mechanical system, translational mechanical system. So, we have 1B, or we have one damper or friction, we have 1K, or we have one spring, and we have 1M, or we have one mass. There's a force acting on it having this displacement going downward. So writing a force balance equation of the system, the force is equivalent, or the force acting on the system is equivalent to the summation of all the force of your element, or the opposing force of your element. There's opposing force for your mass, there's opposing force for your damper, and there's opposing force for your spring. So, nakuha naman natin yung mga equivalent equations na differential equation kanina. This is second discussions natin. Therefore, the force acting on your body is equivalent to the opposing force acting on your mass, which is equivalent to mass times acceleration, which is d squared x all over dt, plus the opposing force FB, or the opposing force acting on your damper, which is equivalent to B, or coefficient of friction, times your velocity, which is dx all over dt, plus k, which is the force acting on your spring, or it's a spring constant, times the displacement x. So therefore, you have this equation 1. So in this case, this is the force or the equation of the force of your system, mechanical system here. Nakukuha po ba? This is your mechanical system. And when we write the equation or the force balance equation in a differential form, this will be your equation. Okay, the equation 1. Nakukuha po?
Yes, sir.
So consider the following electrical system. So meron naman daw tayo electrical system in the figure. So the circuit consists of a resistor, inductor, and capacitor. There is a tig-iisang element din. We have one resistor, one inductor, and one capacitor. So all these electrical elements are connected in series. So connected in series meaning you have a voltage drop. So therefore you will have an analysis based on the voltage of your electrical system. So the input voltage applied to this circuit is V volts, and the current flowing through the circuit is I amperes or I amps. So when we analyze this electrical system, so you have this electrical system, you have a voltage applied, and you have a current that is flowing through your circuit, is designated by I in amperes. So you have three elements or electrical elements: resistor, inductor, and capacitor, all connected in series. So in this force voltage analysis, you analyze the voltage because there's only one current, and there will be what? There will be voltage drop across resistor, across inductor, and across capacitor. That's why we are analyzing in terms of your voltage. So writing in mesh equation, so total voltage V is equals to your summation of all the voltage drop, katulad nung na-discuss natin during our first discussion. So in terms of differential equation of this system, so we can write that the voltage drop across the resistor is Ri times L di all over dt. Ito talaga siya. So the voltage drop is Ri times L di all over dt plus 1 all over C integral of I dt. So this will be your mesh equation for this electrical circuit. However, when we substitute the current into dq, into charge all over time, which is charge all over time, dq all over dt, we can come up with the differential equation of this equation 2. So we can have a differential equation of your equation 2, which is equivalent to your equation 3. So sabi lang, ita-transfer lang naman natin tong current into this change in charge all over time. So R dito magiging R times I, which is dq all over dt, plus L, copy lang natin yung L. Since meron ka ng di all over dt dito, so you have this dq squared, d squared q all over dt squared, plus the integral of IC the integral of I dt. Therefore, you have this q all over c. So therefore, magiging final equation mo, differential equation, mathematical model of your force voltage analogy is V is equal to L d squared q all over dt squared plus R dq all over dt plus 1 all over c q. So this will be your final differential equation mathematical model of your electrical system. So therefore, we now can compare the two systems. By comparing equation 1 and equation 3, we now comparing two different systems. So sabi, pwede ba natin i-compare siya, analogy or analogous system? So therefore, sabi natin, kailangan natin masatisfy yung dalawang condition. First, dapat they are physically different. And then the same time, yung kanyang differential equation are the same. Kung titingnan natin, both system are different. Magkaiba pala yung each system kasi first is a mechanical system, and the second one is electrical system. Therefore, we meet the condition 1. And the second condition is that their differential equation must be the same. Kung titingnan natin yung equation 1, saka equation 3, medyo binibilisan na natin 11, ano na ba? Equation 1, ito yung equation 1 mo. F is equals to N. Ito yung kanyang differential equation. And then equation 3, voltage, in terms of voltage, this one. V is equals to LDC squared. Kung mapapansin mo, parehas yung kanyang differential equation. Bakit? Meron kang second order dito, meron kang first order dito, and then wala ka dito ng differentiation. And then sa labas mo, yung kanina equivalent sa force, dito equivalent sa voltage. So when we write the table and analyze it accordingly, so we can come up with these analogous quantities of the table. So si force mo, since nandito siya sa left side, equivalent siya sa voltage. Tama? Kasi ito siya. Ito si voltage sa force kanina. Isa dito. Ito siya. So therefore, when we, si force equals sa voltage, si mass, siya equivalent itong mass na to. Since kaduktong siya nung second order differentiation, siya equivalent si mass. Equivalent si mass mo sa L or sa inductor mo. Therefore, when we go into the table, si mass, equivalent siya sa L sa inductor. So this is the analogy of your force voltage analogy. So kung mapapansin mo, it's summarized in this table. The force is equivalent to your voltage. The mass is equivalent to your inductance according to your writing of your differential equation. The frictional coefficient B is analogous or equivalent to your resistance. The spring constant K is analogous or equivalent to reciprocal of capacitance or 1 all over C. The displacement X is equivalent to your charge Q, and the velocity is equivalent to your current. So that will be similarly, there are torque voltage analogies for rotational. Let us now discuss about this analogy. So kung nakita nyo sa translational, ito yung equivalent niya. We can also compare it into translational. The translational, di ba ito? Kunyari, ito yung mechanical system o translational. You have this damper B, you have moment of inertia J, and you have this torque applied in terms of T, and you have this displacement equivalent to theta. So the torque balance equation, therefore, will be what? So you have T is equals to TJ plus TB, or the force acting on the damper, and you have the TK, which is the force acting on the spring, or rotational spring. So when we convert it into, or when we write this equation into differential equation, therefore the applied torque is equivalent to all the summation of the opposing torques, which is in a differential equivalent. So it's equivalent, the TJ is equivalent to J times the angular acceleration equivalent to d squared theta all over dt, plus the opposing TB, or the torque B of your damper is equivalent to B, or coefficient of friction, times your velocity, which is equivalent to d theta all over dt, plus the spring, which is equivalent to spring coefficient K, times your angular displacement theta. So therefore, by comparing equation 4, this equation, into the electrical system na nakuha natin kanina, into this one, you can also have, say that the rotational mechanical system is physically different than your electrical system, but they also have a same differential equation because of this one. So therefore, you can now compare the rotational equivalent analogous of your rotational mechanical system into your electrical system, and this is the summary table of your rotational mechanical system into your electrical system. So you have the torque equivalent to voltage, the moment of inertia equivalent to inductance, the rotational friction coefficient equivalent to resistance, the torsional spring coefficient equivalent to reciprocal of capacitance, and then you have the angular displacement equivalent to charge. So also you have this angular velocity omega equivalent to your current. So those are the different analogies of electrical analogy in comparison to your translational and rotational mechanical system. Okay? Nagigets po ba?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
In the second type of analogy, you have the force current. Ang tandaan nyo na lang dito, class, para hindi kayo malito. Kung kanina, inanalyze natin siya sa electrical system based sa voltage, because you have a series of electrical element, series of resistor, inductor, and capacitor. So you have different voltage drop and only one current acting on it. However, in force current, analogy. So you are now taking into consideration the current or the analysis based on the current of your electrical system. So in this case, we can now analyze daw yung mathematically yung translational and rotational mechanical system based sa force current analogy. Kunin muna natin yung current. For example, when we are analyzing a force current analogy, we need to consider a nodal equation. Because bakit? Pag series, ang nangyayari sa series, isa lang ang current, tama? Pero ang voltage ang nagkakaroon ng analogy kasi ang nagkakaroon ng voltage drop in each element. However, when we need to analyze it in a force current analogy, we need to have an electrical system that is being all the electrical elements that are in parallel. Kasi when we have a connections of all the electrical elements in parallel, the voltage across all the electrical elements are the same. Tama? It's equivalent to your voltage input. Diba? However, the current are divided into different nodes or different branches. So therefore, you have different currents according to different branches or different nodes. Tama? You have the current across resistance, you have a different current across the inductor, and you have a different value of the current across your capacitor. And therefore, your total current I is what? What is your total current I? Equivalent to the summation of all the currents. Tama? It's equivalent to all the summation of the currents across your circuit. The summation of the current across the R plus the current across the L plus the current across the C. So the sum of all those three currents in these three nodes is equivalent to your I or your total current. Tama ba? So therefore, when we equate it, so current or your total current I is equivalent to V all over R, or in this case, it's an Ohm's law, to get the current in the branch or in the node R. And then for the inductor, this is the formula for your current. This is a standard formula for your inductor. And to get the current for your capacitor, this is a formula for the current in the capacitor, across your capacitor. So therefore, when writing it into differential equation, so you have this voltage is equivalent to what? To dG all over dt, or this is the flux or d flux or dG all over dt. So transfer this equation, substitute this dG all over dt or d flux all over dt. So makukuha natin itong itong mga V lang naman ang babaguhin natin. So therefore, you can come up to this equation 6, which is 1 all over R of your this one, kasi ito yung V. 1 all over R of dG all over dt plus 1 all over L of your, meron kang V dito, of dt. Since it's a differentiation, it's integral, so maka-cancel, it's only dt. And then, you have C dV all over dt. Therefore, may A squared mo siya. O, D squared G all over dt. Ayan, D squared G all over dt. So therefore, ito na yung magiging equation mo, differential equation in terms of current. So, writing it according to its order, so mauuna si second order differential equation. So, current is equal to C times D squared G all over dt squared plus 1 all over R dG all over dt plus 1 all over L of G or your flux. So, in this case, in descending order na yung differential equation or yung equation mo according to the order of your differentiation. So, therefore, you can now compare equation 6 into your first equation, which is the electrical, which is your mechanical translational. Tama? Nakuha mo yung translational. So, ang gagamitin na natin, imbes na yung sa force current, imbes yung voltage na nakuha natin equation, i-compare na natin to in terms of current kasi force current analogy na tayo. So, i-compare, saan equivalent itong si C? Tingnan mo na lang equation 1 dun sa translational mo. So, kung ito si current, C, current I pala rather, current I, this one, equivalent na niya is force dun sa equation 1 mo. Itong capacitance mo, since ito yung nasa second order differential equation mo, tingnan mo yung translational mechanical model mo kung ano yung nasa second order differential equation mo. And malamang-lamang si mass yun kasi ito yung nasa table. So therefore, analogous siya sa mass. And so on and so forth, si frictional coefficient, analogous siya sa reciprocal of resistance. Si spring constant, analogous sa reciprocal of inductance. Si displacement, analogous ka kay magnetic flux. At si velocity, analogous ka kay voltage. So, dun lang yun. Pagdating mo naman sa torque current analogy, so it's rotational siya. So, i-arrange mo lang din according to the degree of differentiation. And then you will come up. Kasi diba, this is your degree of differentiation of your current analogy. Kung force current, it will be the torque current. So, i-arrange mo lang to descending order mula sa highest order differentiation up to the lowest order. And therefore, i-compare mo siya dun sa rotational or mechanical, translational or rotational mechanical system mo. And then you can have the equivalent of those translational and rotational model. So, kung rotational torque is equivalent to current, moment of inertia is equivalent to capacitance, rotational friction is equivalent to reciprocal of resistance, torsional spring is equivalent to reciprocal of inductance, angular displacement is equivalent to magnetic flux, and angular velocity is equivalent to the voltage. Okay? So, nakukuha po ba? Nakukuha po yung analogy. Okay, so now I'll give you just 2 examples na lang before we end this discussion para mas maintindihan natin kung paano ba nagkakaroon ng modeling of a system or control system mathematically. So in this case, modeling of system mechanical. So example, you have a spring, mass, and damper system. Diba? So it's a mechanical system. Example, you have a mechanical system having a spring, mass, damper system. So you draw it. This is the system. So you have a spring K, you have a damper B, and you have a mass M. You have a force acting on it, which is equivalent to F. Malalaki yung ba siya? Yan. And then you have displacement equivalent to X. So therefore, summing of all the forces across the horizontal, alam naman natin the summation of force or the force acting on your body or yung in-applied force is equivalent to all your opposing force. Since you have 3 basic elements, o tigigisa lang yan, class, kung kunyari dalawang spring, ibig sabihin dalawa na yung spring element na mag-ano na yon. So i-add mo lang siya dito sa equation dito. Kung dalawang friction, dalawang damper, o tatlong mass, i-add mo lang siya. But basically, ito lang din siya. When we analyze it in a basic form, so you have 1 damper, you have 1 spring, and you have 1 mass. With 1 applied force acting on it, and therefore you have an output displacement. Therefore, the summation of forces is equivalent, the applied force is equivalent to all the opposing force of your mass, opposing force of your spring, and opposing force of your B or your damper. For example, mechanical spring mass damper system. In this example, we model the spring mass system shown in figure. So the mass is in M subject to the external force F. And let's suppose that we are interested in controlling the position of M. Therefore, we need to know the output position or the X or the displacement. So the way to control the position of the mass is by choosing F. So kung paano daw natin i-control yung position ng M is by choosing F or kung gaano kalaki yung force na ilalagay natin doon sa mass para makontrol natin kung gaano yung kalayo yung magiging displacement niya. So therefore, we first identify the input and the output. So ano ba yung input and output natin? So therefore, the input is the applied force or the external force applied to the system. Tama? And the output, ano magiging output niya? Is the position of your body or the position of your mass or the X. Sabi natin. As you can see, when we write it into mathematical model, so you have the summation of F of force is equivalent to mass times acceleration, which is equivalent to what? Your F or the applied force minus the force S or force on your spring minus force in the or force in your damper. Actually, is equals, ito ay minus force in your what? Mass, which is mass times acceleration, which is equivalent to 0. So, inire-write lang niya ng ganito. So, when we rewrite it in this case, so force is equals to F minus Kx kasi ito spring. Ito pa rin naman yun, Kx. Diba? Pag damper, it's B times the what? Velocity, dx all over dt. Tama ba? Tatandaan nyo? Pag force ng mass, it's always mass times the acceleration, which is d squared x all over dt squared. I-rearrange mo lang, ganun din siya. I-rearrange lang natin according to the highest degree differential order. So in descending order, it's mass times the acceleration d squared x all over dt squared plus add lang natin yung this one, the damper b times the velocity dx all over dt plus the spring coefficient k times what? Times the displacement x, which is equivalent to your applied force. So this will be your final answer in this mechanical system. So your applied force is equivalent to all your external, the applied external force is equivalent to all the opposing force. This is the opposing force for your mass. This is the opposing force because of the friction. And this is the opposing force because of the spring. Okay? Nakukuha po?
Yes, sir.
So when we apply it naman daw into, or when we convert it into transfer function, so using the same equation. Ito basahin nyo na lang, nandiyan yung mga equivalent niya. So, for example, this one, di ba ito rin naman yung system natin kanina, this is a mechanical system. Tama? Na pinakita natin kanina. When we use, kung kanina, ang kinuha natin is differential equation model, now we will get the transfer function model of your mechanical system. So in this case, alam natin yung transfer function. This is a block diagram of transfer function. You should have the output and you should have the input. Tama ba? And therefore, yung nasa loob ng box is the transfer function. Tama po? Before we can up this, kailangan natin siyang isolve. Paano natin siya isolve? So we need to know what is the input, what is the output, and what is the transfer function, so that we can know what is the transfer function, which will be written in the box. Alam naman natin, ano sabi natin, ano yung input natin doon sa system kanina? Ano po yung input natin?
Alin, sir, sa voltage or sa current?
Hindi, dito po sa mechanical system natin.
Yung
Anong input natin kanina?
Force.
The force or the external force applied. This one. Tama? Itong F of T. Tama?
Opo.
yes, sir.
Ano yung output natin? Sabi natin, di ba yung output kanina is what? Displacement, di ba? Ayan. The output is a mass position X or the displacement. The input is external force and the output is the displacement X. So when we analyze it, kung differential equation model ang hinahanap, mathematical model, tapos na tayo dito. Ito na yun. Ito na yung sagot natin sa mathematical differential equation model of your system. However, when the question is, get the transfer function model of this system, hindi ka dito matatapos. So, kailangan mo to. So, yung transfer function model, sabi natin, hindi siya matatapos. But we already know and identify the input. The input is a force, external force, and the output is the displacement of your system, or x of t. Therefore, initially wala pa tong laman. So find the transfer function. So x of s all over f of s. Kasi in terms of s na ang ating transfer function, sabi natin, it's an s domain function. So therefore, when we analyze the system, when we solve the system, sabi natin there is a force applied. Tama? There's a force applied, and because there's a force applied, there's an equivalent opposing force. Opposing force of your spring, opposing force of your damper, and opposing force because of your mass. Tigigisang opposing force kasi tigigisang element pa lang naman tayo dito sa example. So meron kang isang opposing force because of the mass, may isang kang opposing force because of the spring, and meron kang isang opposing force because of your damper. So when you write it, so para din naman siyang ganito, in a Laplace transform. So ito na siya, ito yung Laplace transform niya. There is an opposing force of your spring, opposing force of your damper, and opposing force of your mass. So when you write it, di ba kanina hindi ito? Ito yung kanina mo, di ba? Ito yung differential equation model mo kanina doon sa una nating sinagutan. Tama ba? Tama po ba? O nire-write lang natin siya in terms of ni-arrange natin siya ng ganito, diba? F, kung matatandaan nyo, is what? F of t. is equals to mass times t squared x all over what? dt squared plus ano? B yung kanina, di ba? B of dx all over dt plus ano yung kanina? K of x. Tama po ba?
Opo, sir.
A of x, yes, sir.
Ayan, ito siya, di ba? M dx squared, d squared x all over dt plus b, maliit na bilang pala yan. Ay, nawala. Sige, sulat na lang ulit natin. Mas small b squared x all over dt plus b of x all over dt plus k of x is equivalent to f. Tama? So, yan yun. So, kung ano, ito rin naman yun na iba lang yung pagkaka-arrange dito sa example. Pero basically, ito rin siya. Di ba? Ito rin siya. Itong unang equation. Tama? Yan din yun. So, when we want to know the transfer function, sabi natin, let us first transfer your differential equation model into what? Laplace transform. Tama? So, kung natatandaan nyo, paano tayo nagla-Laplace transform? Itong M, magiging big M. And then, since ito ay second order, ilang S? Squared yung S natin. Tama? So, ito na siya. Tama po ba? Then, it's a function of x of S. This one, x. Nakukuha po ba? Natatandaan?
Yes, sir.
So, itong F, ito siya. Itong output. Magiging siyang, kung kanina F of T ito, so magiging siyang F of S. Minus, ito ay yung sa, ano to? Sa B. Ito na siya. Yung sa damper mo. Which is d of x all over dx. Dt. It's dt. It's dt. Sorry. So, mangyayari, since isa lang yung order differential, ilan yung s mo? Isa lang. Tama? Actually, ito yung B din. Pwede din itong B. Kung B ang gagamitin natin. So, pwede din siyang B. B of S times X of S. Tama? And then itong F of K, it is K. Pwede nating capital K na lang. Diba? Yung sa mga example natin kanina ng Laplace, K of X of S. So, therefore, you can now isolate your input, which is what? The input is F of S, which is your force. All over the what? All over the output, which is what? X of S, or ito. Therefore, when we have this transfer function, which is the output all over the input, X of S all over F of S, we will have this one. Transfer function na may isusulat mo na dito. So, equivalent din siya. Isusulat natin siya kung, kasi dito ay ginamit F of B. Pero ito ay kadalasan ginagamit natin sa examples natin kanina. Dito sa spring, ang ginagamit natin, malaking K. Therefore, mangyayari sa kanya is 1 all over what? Mas pa rin to, ms squared, tama? Plus, what? Ano to? B. B of S plus K. Tama ba? So, equivalent naman yan. Parehas yan. Ang kukuha po, so ito is ginamit natin is transfer function na mathematical model. So I think that will be all for the second contact session. So stop ko na yung recording. So I think we discussed everything from the mathematical models of the system, the modeling of mechanical system, the electrical analogies of the mechanical system, and then we have examples of those different modeling of your control system. So I'll start the discussion for today. So I don't. Okay, class, that will be all for the control engineering midterm period. So, diniscuss natin is yung ating yung electrical analogy of your mechanical system. We just compare your mechanical system, both translational and rotational into an electrical analogy. So, sabi natin dyan, we have two parameters or we have two conditions para may-compare daw natin yung ating system. First is that your system must be different. So, dapat daw magkaiba yung system natin. So, basically, yung ating mechanical at electrical, magkaibang two different system siya. Kaya pwede natin siyang i-compare. And the second condition is that their differential equation must be equal. So, kaya natin siya na-compare o kaya siya naging analogous sa isa't isa. Kasi when we write the mathematical equation of your electrical system and your mechanical system, their mathematical model, particularly or specifically, yung kanilang differential equation mathematical model are the same. So, paano lang natin kino-compare? Kung alin yung may second order, alin yung may first order differential. So, kung ano yung variable na kasama nun sa mechanical in comparison to sa electrical, yun yung kanyang analogous variable. So, pwede natin siyang i-compare. So, we have two types of analogy in electrical. We have the force voltage analogy and the second type is a force current analogy. So, depending on what electrical parameter we analyze, yun yung magiging analogy natin. Kanina, kung voltage yung in-analyze natin, it should be analyzed sa electrical parameters in series because yung current natin sa series iisa, but the voltage is magkakaiba because of the voltage drop. But when we choose to analyze it using force current analogy, your electrical parameter or your electrical elements must be in parallel because of different branches of current na pwede nating ma-produce or makuha because of that parallel connection of your electrical element. And then the last thing we discuss is the examples. We give two examples. First is the writing or analyzing your mechanical system used and having the final answer in differential equation model. And the last one is the same example but using a transfer function model. So, in-analyze natin siya using your transfer function model. Parehas yung example, parehas yung system. We have tigigisang element lang, one mass, one spring, tsaka one damper. But we analyze it. We use or we give example depending on ano yung final answer na hinihingi. Yung una is differential equation mathematical model and the second one is the transfer function mathematical model. But basically they are the same. So ma-analyze mo na lang siya kasi ang general rule lang naman dyan is the summation of force is equal or your force is equal to the summation of all the parang resisting forces na nagre-resist dun sa force na in-applied mo or dun sa equivalent na in-apply mong force. So, yun lang naman. Kung dalawa ang spring niyan, therefore, dalawa yung element na mapupunta dun sa equation. Kung dalawa yung mass, dalawa din yung element, resisting element or resisting force na mapupunta dun sa iyong mathematical equation. So, questions po? That will be all. Kung ano man, our exam will be on Thursday next week. Yung exam natin. So I will upload until weekend yung recording para ma-replay nyo and at the same time I will upload the presentation para mabasa nyo na rin for your advanced reading before matapos tong week na to. Okay? Any questions po? Wala. Kung wala na, so I will check the attendance. So when I call your name, just say present. Just say last name, your last name and say present. Okay? So, first, Abayro.
Abayro present.
Abehar.
Abihar present.
Almacen.